Okay, good morning everyone. So today we will still continue our discussion about fluid flow, but maybe I'll try to recap what we have discussed previously. Okay, please remember again the concept of Reynolds number and how to calculate the Reynolds number based on the information provided, because basically you need the value of fluid density, the pipe diameters, and then fluid velocity and the fluid viscosity. And then you have also learned about how to calculate what we call equivalent diameters or hydraulic diameters. This is to basically you need to calculate the equivalent diameters in order to calculate the Reynolds number when you have a situation where liquid flowing inside the pipe and the appearance of the pipe is not, the cross section of the pipe is not circular, or the liquid is not fully filled the pipeline. Yeah, so this is for a liquid case. And then the pipe itself comes in different sizes in terms of nominal pipe size, and then it also have parameters what we call schedule number. So based on the schedule number and nominal pipe size, you can get the information from the handbook or the table provided. What is the wall thickness, and then you can calculate the inside diameters, because basically when you calculate the diameters, if the liquid or the gas flowing in liquid or the gas will flow normally inside the pipe, right? So the diameter used is the inside diameters. But if you have this kind of arrangement, what we call annulus pipe, then you need the value of diameters of the inner pipe and inside diameter of the outer pipe. So it depends on the situation where the fluid is flowing. Yeah. So the diameters is generally is the inside diameters. Okay, and then we have learned about the mass balance equation in flowing fluid. So basically, for just liquid or gas flowing inside the pipeline, you can assume first it is a steady state. Steady state means no accumulation. So the rate of mass accumulation is equal 0. And then for just liquid flowing or just gas flowing, it will be no reaction. So for no reaction, you can say that the flow rate of the mass that flowing into the system will be equal to the flow rate of the mass flowing out the system. Yeah, we call it continuity equation. Yeah, like the fluid flowing from one end of the pipe goes to another end of the pipe. Then what we can say about this flow is the mass flow rate will be equals in every point. So mass flow rate at point 1 will be equal at mass flow rate at point 2. But for liquid, yeah, or we can say for any incompressible fluid means the density will equals. So throughout the flow, the density will equals. So the density at point 1 will be equals with the density at point 2. It means if the fluid is incompressible, the density is constant, then the continuity equation can be written as this one. So the volumetric flow rate will be the same throughout the pipeline. Yeah, the constant volumetric flow rate will be applied only if the density is constant. Otherwise, if the density is not constant, or for compressible fluid, just the mass flow rate will be constant throughout the flow. Ya, jadi yang dasarnya itu adalah laju massa konstan. Apapun kondisinya, laju massa konstan selama alirannya tunak dan tidak ada reaksi. Ya, kalau densitasnya konstan, baru bisa dikatakan laju volumetriknya yang konstan. Ini hanya berlaku kalau densitas konstan atau fluidanya adalah incompressible. Okay, that's about the mass balance. So basically, you can use this mass balance principle to calculate various cases of fluid flow. We have discussed some of the exercise. So do you have any question regarding the previous exercise? Any question first? No? Then if you have no question, I hope you understand. And then we have a bit discussed about the Bernoulli equation. Bernoulli equation is basically the energy balance of flowing fluid. When fluid is flowing, so you can say that the first law of thermodynamics is applied. This is about the conservation of energy. It said the total energy of the system will be constant. And energy can be the total will be constant, but energy can be change the form. It can be transformed from one form to another, and then the energy level of object, including flowing fluid, can be expressed as the energy level relative to a certain energy level. Ya, jadi energi itu kalau di termo ya, belajar dari termo, itu kan konstan, hanya bisa berubah bentuk. Artinya totalnya tapi konstan ya, dengan asumsi tidak ada energi yang hilang ya. Oke, kemudian cara menyatakan tingkat energi dari suatu objek, ya, termasuk fluida yang mengalir, tingkat energinya itu biasanya nanti ada yang namanya datumnya, baseline-nya. Ya. Apakah pada temperatur tertentu, atau ketinggian tertentu, atau lokasi tertentu. Oke. So basically we have 4 forms of energy, ya. When fluid is flowing throughout the pipeline. So first we call it internal energy. Yeah, internal energy. Yeah, the symbol in this lecture will be En. Yeah. Then what is the unit of energy? The standard unit of energy? Anyone still remember?
Joules.
Yeah, the unit will be joules. This is the SI unit for energy. Okay, so if we calculate the internal energy of flowing fluid, yeah, it means for the internal energy of flowing fluid will be depending on the temperature of the fluid. Yeah. So how to express the internal energy? It will be correlated with the mass of the fluid times CV. Have you learned about CV in thermodynamics class? What is the definition of CV? Ada yang ingat?
Heat
Atau sudah
capacity
dapat
in
ini?
constant volume.
Sorry?
Heat capacity measured in constant volume.
Yes, correct. So it basically heat capacity of the fluid. It was calculated when the volume is constant. Yeah. So basically, how to calculate internal energy will be the mass times CV times delta T. This is the differences of the temperature. It means if you want to express the internal energy of flowing fluid, it will be compared to certain temperature as the baseline. Ya, jadi kalau untuk energi internal atau energi dalam itu dipengaruhi oleh temperaturnya. Temperaturnya relatif terhadap temperatur pada kondisi baseline. Sometimes it can be written at room temperature around 20 or 25 degrees C, or sometimes it can be referred as 0 degrees C, depending on the calculation. However, what is important to be mentioned here is if the flowing fluid doesn't change the temperature, it means during the journey if during the journey the fluid doesn't change the temperature, it means delta T will equals 0. Ya, jadi kalau selama mengalir fluida itu tidak berubah temperaturnya, what is the condition when the temperature is constant?
Isothermal, sir.
Yes, it's isothermal condition. It means there is no internal energy change in fluid flow. Yeah, it only changes if the temperature is changed. Sometimes the temperature can be changed if there is some energy loss as heat, then maybe the temperature will decrease. But when there is no energy loss, the temperature or the pipeline is ideally insulated, for example, so there won't be any heat loss or there won't be any heat coming into the pipeline, then we can say the process is isothermal, and then there is no change in internal energy. Okay, the second one is the kinetic energy. The kinetic energy is the types of energy that influenced by velocity. Yeah, because during the fluid flow, the fluid will have certain velocity. It may change the velocity during the journey. So how to calculate the energy, the kinetic energy? It will be this one, half times mass times quadratic of the velocity. The unit for this energy is the same. It's joules. It means if during the flow the velocity remains constant, then you can say the kinetic energy is constant. There is no change in kinetic energy. Okay, the third one is potential energy. So potential energy is the energy that contained in fluid flow due to the heat of the fluid. Yeah, so remember again that in complex chemical plant, you will see very chaotic or very complex pipe arrangement, right? It won't be just one horizontal pipeline with the same height. It will be like go upward, go downward, and then some fittings are also installed. So the potential energy is the energy that contained in fluid flow because the fluid have a certain height, a certain position related to the baseline. So maybe the baseline can be the ground. Yeah. So if the height of the fluid or the arrangement of the pipeline is just one straight horizontal pipeline, it means there is no change of height, so there is no change of potential energy. So the potential energy is calculated this one, mass times gravitation times the height. The unit, same, joules. Okay, the last one will be the pressure energy. So the pressure energy is the energy that contained in fluid flow because the flow will have certain pressure. Pressure is force divided by area. Okay, how to calculate the pressure energy is the pressure times volume. Yeah, so you need to understand each type of the energy. This is volume. So the unit same, yeah. The unit of this one will also is joules. This is the energy. Sometimes you can express energy in terms of this one, specific energy. This is energy divided by mass. Yeah, you can see from the equation. So all the energy you can divide it by the mass. It means the unit becomes joules per kilogram. Ya, jadi Anda bisa juga menyatakan selain dalam energi satuannya joules, Anda bisa nyatakan juga dalam bentuk spesifik energi atau energi spesifik itu adalah energi dibagi massa, sehingga satuannya adalah joules per kilogram. Okay, any question until this part? Okay, then I continue with the Bernoulli equation. I think you have learned from our previous class. So basically, Bernoulli equation is the very ideal energy balance equation for flowing fluid or for fluid flow. Yeah, this is the energy balance of flowing ideal fluid. What will be considered as ideal? So in fluid flow, which follow Bernoulli equation, there won't be any energy loss. So there are no loss of no energy loss, and then there's also no additional energy inputted to the system, or there is no any energy that worked by the system. Yeah, this is the assumption that used in Bernoulli equation. It means, yeah, the previous assumption still applied, so the flow can be considered steady state, ya. Jadi di persamaan Bernoulli itu Anda bisa mengasumsikan bahwa alirannya adalah steady state, then there is no energy loss, no incoming energy. It means there is no energy inputted to the system, and there is no work done by the system. Ya, tidak ada energi yang hilang. Dalam aliran itu tidak ada energi yang ditambahkan, ya, dan tidak ada juga kerja yang dikeluarkan. Artinya tidak ada energi yang keluar dari aliran. Okay, this is the three assumption of Bernoulli equation. So it's very ideal fluid flow. So the component will be only from, because there is no energy loss, there won't be any change of internal energy, right? Yeah, because there is no energy loss, there is no work done, and there is no energy inputted to the system. It means there is no internal energy change. However, for three other types of energy still can be changed during the fluid flow. It means for this Bernoulli equation, the component of energy will only be the pressure energy, potential energy, and kinetic energy. Ya, jadi komponen dari Bernoulli, ya, karena ideal, ya, tidak ada energi yang hilang, tidak ada energi masuk, tidak ada energi keluar, gitu ya. Komponennya hanya energi tekanan, energi potensial, dan energi kinetik. Okay, so if you analyze just point A and point B, so this is the pump. Pump, I think we have explained in our first session that the function of the pump is to add more energy, because during the fluid flow there will be energy loss, right? In actual case, there will be energy loss, so we need to supply more energy using pump. But for now, just consider the pipe, yeah. Don't consider the work done by the pump first. So basically, in this figure, you can see the fluid is flowing from point A and then goes up to point B. Yeah. So you can see that point A will have different height with point B. The height of point A you can calculate at ZA. ZA is the distance between the baseline. So maybe this is the baseline, and then we can say at the baseline, okay, Z will be equals 0. So this is the ZA, yeah, this is, and this is the ZB. So the component of the energy in Bernoulli equation, Yeah, you can see from this one. Okay, if you are using this equation, yeah, pressure divided by the density, then gravitation times height, then velocity, quadratic of the velocity divided by 2. What will be the unit of each component of the energy? Satuannya apa? So if you are using this term, so this is the pressure energy. This is the potential energy. And this is the kinetic energy. However, the unit of each component is not joules. What will be the unit?
Meter square per second square.
Meter square per second square. Okay, based on this one, right?
Yeah.
So what will be the unit if the kinetic energy, if the unit is joules, it will be this one, right? This one, right? If you have joules as the unit. So the full term is this one, half time mass times velocity square. So if you just have this one, only this one, it means the unit will be joules per kilogram because you already divided by the mass. Yeah, meter square per second half then. Yeah, so for this one is meter square per second square. This one will be this one. Yeah, this one will be, yeah, actually the same, but basically you can convert meter square per second square as joules per kilogram. Bisa dipahami ya? You can understand, or anyone still confused why the unit becomes joule per kilograms? Ada yang masih bingung? The same with the potential energy. The full term, if the unit will be joules, will be this one, right? This one. Since you only have G times height, then the unit will be joules per kilogram. Expressing the unit as joules per kilograms, I think is more sensible than meter square over second square. So basically, this term is the specific energy. Ya. Jadi di komponen Bernoulli itu hanya ada 3 jenis ya, ada energi tekan, ada energi potensial, ada energi kinetik. Tapi menyatakannya tidak harus dalam satuan joules. Bisa dalam satuan joules per kilogram. In this slide, the unit will be joules per kilogram, or we call it specific energy. Any question until this point? Okay. And then if we compare point A and point B, you can write down the equation because the total energy will remain constant. It means the total energy at point A, which is this one, will be the same as point B, which is this one. Yeah, the total. Okay. Then if you take the delta, delta means the differences, then you can write like this one. So the total of the delta of pressure energy plus potential energy plus kinetic energy will equals 0. Okay, if you see this arrangement, this is point A, this is point B, which one? what types of energy that will change that will transform the value. Ya, kalau Anda lihat ya, ini posisi A di sini, posisi B di sini, energi apa yang berubah jumlahnya?
Is it the potential?
Yes, the most obvious one will be the potential energy between point A and point B will not be similar, right? Because ZA is lower than ZB. Yeah, so there will be a transformation, or there will be change in terms of potential energy from point A to point B. Okay, it means if the value of potential energy is changed from point A to point B, it has to be compensated to other types of energy. Ya kan? Karena energi potensialnya berubah, ya, ZB lebih tinggi, berarti kan energi potensialnya berubah. Bertambah atau berkurang? From A to B, the potential energy will increase or decrease?
Increase.
Increase, yeah, correct. Because point B is higher. It means there will be increase of potential energy. It means either pressure energy or kinetic energy should decrease to compensate the increase of potential energy. Which one do you think that most likely to decrease? The pressure or the velocity? It's quite difficult to see the participant list if I share slide. Just a sec. Okay, let us, or anyone will want to try to.
Is it pressure, sir?
Yes, Ahmad.
Is it pressure?
Why you think the pressure will decrease?
I took an example from the sea.
From the?
When the height increase, the pressure decreases. Yes.
Yeah.
I don't know. I took it from real life example.
Yeah, actually your answer is correct. Normally, or yeah, intuitively, if you have a fluid flowing through the pipeline, and then the pipeline are increasing the height, yeah, I mean the pipeline is going up, it means the potential energy is increased. It has to be compensated by other types of energy, and the one that decrease is usually the pressure. How about the velocity? If you have constant diameters, yeah. If you have constant diameters, yeah, it means the diameter of the pipe is the same, right? From point A until point B. If the diameters A is equals to diameters B, it means the cross area in point A will also same as the cross area at point B, right? If only the diameters is constant. Please remember again the continuity equation. Yeah, the mass flow rate at point A will be the same as mass flow rate at point B. Yeah, the mass conservation will always apply for any fluid flow situation. But if then you can assume that the density is constant, you will have volumetric flow rate at point A the same as volumetric flow rate at point B. Yeah, the velocity is v in here. This is velocity. Velocity will be volumetric flow rate divided by cross area. So if you have same volumetric flow rate and the same cross area, then velocity at point A will the same as velocity at point B. Only if all the assumption is correct. The assumption is it's correct. Yeah, the diameter you can if the diameter is constant, then cross area is constant. If the density is constant, then the volumetric flow rate is also constant. So if you have constant volumetric flow rate and constant cross area, you will have constant velocity. It means if you have constant velocity, there is no change of kinetic energy. Ya, kalau kecepatannya konstan tidak berubah ya. Ini simbolnya agak ya. A dengan B kecepatannya sama, berarti tidak ada perubahan energi kinetik. Kalau if the potential energy is increased, there is no change in kinetic energy. It means the pressure energy should decrease. So the pressure at A will be higher pressure at B because ZA is lower than ZB. Okay, do you have any question? Okay. Before we are going to the figures, this is also the Bernoulli equation. Yeah, Bernoulli equation. This is the pressure energy. This is the this is the potential energy. This is the kinetic energy. But you can see what will be the unit of the energy. It's not joules or joules per kilogram. Ya, jadi ini adalah persamaan Bernoulli ya, titik 1 dan titik 2, totalnya sama. Ini energi tekan, ini energi potensial, ini energi kinetik. Tapi satuannya sudah bukan joule maupun joule per kilogram. Apa satuannya? What will be the unit?
Meters.
Yeah, the unit will be meters. So this is energy, but the unit will be length. This we call head. Yeah, head is terms of energy. Yeah, one terms of energy when we express the unit of the energy as length. Ya, jadi cara menyatakan energi dengan satuan panjang, we call it head. So basically head is energy. Head is not length, but the unit is meters for this case. So we can say this is the pressure head, this is the potential head, or we can also call it static head, and this is the velocity head. And the total will be total head. Since the total energy of the fluid is constant, so it means at the point 1, the total energy or the total head at point 1 will be the same as the total head at point 2. Okay, until this point, do you have any questions? Yeah, so you remember again, I mean, just be aware that the Bernoulli equation can be expressed in many terms. In the video, do you remember what will be the unit? Di video yang lalu, unitnya apa? Ada yang masih ingat nggak? What will be the unit of each component? Nobody remember? Okay, the unit, please watch again the video. The unit is pressure. Yeah, the unit will be Pascal or pressure unit. Even though it's not only the pressure energy, right? It's still pressure energy, potential energy, and kinetic energy. But the unit will be pressure. So please be aware. So for the Bernoulli equation, there will be quite numbers of expression. It can be energy, joules. It can be joules per kilogram, yeah, the specific energy, or it can be head, yeah, the meters, the unit will be length, or in terms of pressure. Do you need to memorize all? Actually, no need. You just can take just maybe energy as joules. So you can memorize the equation, and then if you want to convert it to joules per kilograms, then divide it by mass. If you want to divide it, if you want to convert it into head, then you further divide it by the density, etc. Ya, jangan dihafalkan semuanya. Nanti ngabisin memori, silahkan kalian pilih satu bentuk yang paling gampang dihafalkan. Tapi ingat cara mengkonversinya nanti ya. Kalau dikonversi jadi, misalnya dari joule, dikonversi jadi joule per kilogram, dibagi apa, dibagi massa berarti ya. Nanti kalau mau dikonversi jadi head lagi, berarti dibagi dengan densitas, dan seterusnya. Oke. So now we want to use the principle of the Bernoulli equation to analyze this arrangement. Yeah, you have one big tank in point 1. So this is the big. You can consider it. You can consider the tank is quite big. Then it has certain position from the baseline. Yeah, in the baseline, z equals 0. And then Z1, the head of position 1 is calculated from the, let's say this is water, from the water surface until baseline. Okay, at one end of the tank, there will be slanted pipeline. Then the water will flow to this pipeline. Okay, but since the tank is significantly big and the pipe maybe the size is not as big, yeah, it's not big enough. So what will happen? Water can flow through this pipeline, but the head at point 1 remains constant. Ya, ini asumsi sih ya. Jadi asumsi tangkinya itu besar sekali, sehingga walaupun ada pipa di sini, kemudian airnya mengalir melalui pipa, tinggi titik 1 itu konstan. Tidak turun tingginya. Asumsi ya, asumsi. Kalau kondisi nyata ya lama-lama pasti turun. Oke. Then at point 2, the pipeline is connected to what we call manometers, the U-shaped tube. So the some water will flowing to this one until it reaches the static condition, yeah, and the head will be this one. Ya, jadi di sininya mengalir. At this point, the water is flowing, but at this point, the water are filling the manometers. It's not connected. Just the manometers is only connected with the slanted pipe at point 2. It's not connected in this part. Yeah. So at this part, the water is flowing. It's moving. At this part, the water is not moving. Okay, and then from these types of arrangement, basically you can analyze using the Bernoulli equation. So at this point, Z equals Z1. At this point, Z will be equals Z2. Okay, and then the difference between this point, yeah, at this point is basically bahwa apa yang ditunjukkan oleh beda tinggi antara titik ini dengan titik ini. Masih ingat nggak? Kalau manometer. The concept of hydrostatic. Anyone want to try to answer?
What was the question, sir?
What will be the difference between this height, ya, ketinggian di sini dengan ketinggian di sini? Ini kan manometer ya, manometer itu kondisinya statik, walaupun di sini ada air yang mengalir. Apa yang ditunjukkan, what will be expressed by the height difference between this point, ya, the height of the water at the left manometer with the height of the water at the right manometer.
Will they have different pressure, sir?
Yeah, they have different pressure because of where there is any pressure difference between two legs of the manometers.
Because one is at the open air and one is not, sir.
Yeah, correct. Basically, this height difference, this height difference is representing the pressure difference at this point. This is the atmospheric pressure, right? Because it's open to the atmosphere. Same with pressure at point 1. This is also atmospheric pressure. Yeah, the height difference between point 1 and point 2. P2 with atmospheric pressure is lower or higher? Lebih besar tekanan di titik 2 dari atau lebih rendah tekanan 2 daripada tekanan atmosferik? Kira-kira mana yang lebih, tekanan 2 lebih tinggi atau lebih rendah dari tekanan atmosferik?
Is it lebih tinggi, sir? Tekanan
It's
2.
higher. Why?
I don't know. I just think of it's like a mountain and the sea.
Sorry?
The higher the pressure, the less. I mean the. I don't know how to say it. It's like.
The higher the pressure, okay, the less what?
The less height, sir.
The less height. Why? Can you further elaborate? Is less height is caused by higher pressure in this point? No, right? It's vice versa. So you can imagine first at point 1, based on the Bernoulli equation, it will be contain total head or total energy at point 1 will be comes from pressure. Yeah, it has pressure. It atmospheric pressure. Yeah, the energy pressure energy comes from the atmospheric pressure, and then the kinetic energy comes from the height, which is at point 1, and then how about the velocity or the kinetic head, the velocity head? If the tank is in static condition, there is no water movement downwards, ya. Di sini kan karena tangkinya sangat-sangat besar, since the tank is very big, you can assume there is no movement of water. It means the velocity head or the velocity or the kinetic energy will equals 0. Yeah, I hope you can understand. So the pressure comes from the atmospheric pressure, the heads come from Z1, and then U1 will be equals 0 because there is no movement at point 1. However, when the water comes to point 2, it will have velocity at point 2. It's not 0. Yeah, the water is flowing, so the velocity can't be 0, right? It means this one. Ininya 0, U2-nya tidak 0. And then how about Z2? Z2 is lower than Z1. Yeah, since Z2 is lower than Z1, it means the potential energy is decreasing at point 2. Potential energy is decreasing. The velocity head is increasing. Yeah, the kinetic energy is increasing. It means the pressure energy should increase. Paham ya? Karena energi potensialnya turun, energi kinetiknya naik, ya berarti energi tekannya ikut naik. Oke, jadi P2 will be higher than atmospheric, and the differences between P at point 2, pressure at point 2, then atmospheric pressure is calculated by the height difference. Since we express the energy term in head, so the pressure head will be this one. So the remaining, the difference height between this one will be the velocity head. Yeah, so if the total head is like this one, yeah, the total head or the total energy is this one. Okay, at point 2, the total energy should also this one, right? Karena because the total energy will remains constant, the total head will remains constant. But since the static head is changed, the velocity, the pressure head is changed, so the remaining will be the velocity head. Ya, jadi kalau sebagai head, Anda bisa lihat dari ketinggiannya. Anggap dari bawah sampai titik 1 itu total head. Ya, total head. Total head baik di titik 1 maupun titik 2 kan harusnya sama. Nah, karena di sini titik 2 tingginya sudah berkurang, jadi static head-nya sudah berkurang segini, kemudian pressure head-nya bisa dihitung segini, maka yang segini adalah velocity head. Kenapa di sini bisa diasumsikan total head? Anda bisa asumsikan tekanan atmosferik itu kalau dihitung sebagai gauge pressure, it will be equals 0. Ya, as the gauge pressure, you can calculate P1 as 0 because it atmospheric pressure. It means since this one also 0, at point 1, the total head only comes from the static head. That's why at point 2, since you have kinetic head, you have static head, then you also have pressure head. Okay, until this point, do you have any question? I hope you can understand what I explained.
Sir, I want to ask.
Yes, sure.
Yeah. Why was it again that we can express energy in many units?
Yeah, because it's just the unit. Basically, for example, previously we have this one, right? As energy, you can have this formula to calculate the energy. However, if it's just water flowing in the pipeline, the mass or the mass flow rate of the water will be constant, right? Throughout the pipeline. Since the mass is always constant, so you can express the energy as energy divided by the mass because it's constant. Yeah, that's why you have the specific energy. Karena masanya kan konstan terus ya. Jadi sebetulnya bisa juga kan dinyatakan sebagai energi per massa. And then you can also divide it again by the density. Yeah, basically this is the joule per kilogram, but then you can divide it by the, you divide it again by the gravitation. Yeah, you divide it again by the gravitation. All the terms you divide by the gravitation, it's the same, right? Because the gravitation is also constant. It means you can express in terms of specific energy divided by the gravitation becomes head, because the unit become length. Jadi bisa pakai yang mana-mana. Tapi sebetulnya itu semua adalah bentuk energi. Hanya satuannya tidak joules, tidak selalu joules. The unit will not always as joules. So you need to pay attention of the parameters involved in each of the energy component. Okay?
Okay, sir. So it is as if we cancel the parameter that is constant. Is it like that? Oh,
Correct. Yeah.
Okay, thank you, sir.
Any other question? Okay, if you have no question, then I'll stop the recording. Thank you so much for today's session, and we will continue our discussion on Thursday. Thank you and good morning.
Yes, sir.